After completing this lesson, you'll be able to unwrap part faces and edit surfaces by using the patch, repair, sculpt, stitch, and trim tools. On the screen, we have the surfaces that will make up a solid model for a console. To create this solid model, we'll combine these surfaces in a manner that's different than traditional surface-based modeling systems would use. But before we can begin creating that solid, we need to do some additional editing. First, we have Extrusion 2, which rises above Extrusion 3. I want to use Extrusion 3 to trim Extrusion 2 to give it a more complex top edge. So, in the surface panel, which was turned on using the pull down on the 3D Model tab, I'll select the Trim tool. Selecting Extruded Surface 3 as the Trim tool, you can then select the top portion of Extrusion 2, which will highlight in purple. When you click OK, it will remove that top portion of the surface. Then you can turn off Extrusion Surface 3. Now we have a complex edge on the top of Surface 2. To fill that, we'll start the Patch tool from the Surface tools. Select this top edge, and it will immediately offer a preview of that top face just being covered. Instead of doing that though, we want to add curvature to the top. So we'll apply a smooth condition, and it will give us a preview. Changing the value of that smooth condition to say 0.7 will allow the curvature and the direction of the sides to have more influence as to how this patch is blended. Reducing it, say to 0.2, will make the resulting boundary patch flatter, but still maintain curvature to the sides. We'll leave it at 0.2 and click OK. Now let's connect the new boundary patch and the extrusion that it was based on using Stitch. We'll select the boundary patch and this extrusion. Clicking Apply will create a new stitch surface. For the next step, stitching it wasn't 100% necessary, but it can be useful, and it's also a great way to check to make sure that those surfaces are connected very well, because the Sculpt tool, which we'll use next, relies on surfaces overlapping one another and no gaps between any edges. So we'll begin the Sculpt tool and select the stitch surface, either from the browser or on the screen. Then we'll select the Sweep surface. Selecting these two bodies creates a volume that can be turned into a solid model, which is previewed in green. To finish our selection, we'll select Extrusion Surface 1 and the XZ plane. This will add an even larger preview, showing us the lower part of this body. The arrows that appear will allow you to toggle which side geometry would be created on or removed from. In this model, there are no voids, so we won't be able to pick and create a pocket. But to test it, if you click the bottom arrow, it will generate only the lower portion of the model. Or if you click the ball in the middle, it will include everything. When you click OK, it will generate the solid model. Now that we have the solid model, we can use the Fillet tool to grab the edges and add a 0.3 radius G2 fillet. Then, if we want, we can turn off the XZ plane. Now we have our model, but before we shell it or do anything else, we want to make sure that it can be stamped. This will be made out of a thin sheet material and we want to understand how much material it will take to be able to stamp it. Using the Unwrap tool, select the top of the model. After a moment, a preview will appear. You can see the stress concentrations for the stamping. I'll decouple it from the origin by deselecting position at origin. Then we can slide this out, rotate it, and have it accessible. Click OK. It will generate that surface. Now there's a surface that represents the flat material required to generate this part. If we make a modification to the original model, such as editing the original sketch and shortening it from 14 inches to, say, 12.5, when we finish the sketch, it will update not only the model, but it will update the flat as well.